Now I will do this question geometrically. To understand the solution of this question geometrically, I expect that you must be knowing these two very simple concepts, that a to b fx dx represent the area under the curve. The value of this represent this area, you must be knowing it. And second concept which you must be knowing is to draw the graph of y equal to e to the power mod x. You must be knowing that the graph of e to the power mod x is, this point is 0, 1. Because you must be knowing that to draw the graph of this, first I will draw the graph of y equal to e to the power x, whose graph is this point is 0, 1. And to draw the graph of this, that is for x there is mod x. The steps are: remove the portion on the left hand side of y-axis and take the reflection of right hand side in left hand side. This is the graph of y equal to e to the power mod x as I shown here. And third concept which you should remember, that a to b fx dx. Suppose sometimes you want to bring x plus c. If you want to bring x plus c instead of x, you will have to subtract c from lower limit and upper limit. Similarly, if it is x minus c, you will be adding c. Similarly, if you want to bring f cx instead of x, you will have to divide by c. But if you are writing cx for x, you will have to write c outside also. And lastly, if you want to bring x upon c, that is x upon c dx, you will be writing 1 by c, and here you will multiply by c. And lastly, a particular case of this is if you want to bring minus x for x, you will have to write minus here, minus a and minus b. That is for c, I have written minus 1 here. These concepts are very important concepts, very useful concepts. If you don't know these concepts, still you can do the question, but these concepts make your solution very short and simple. To make the question simple, for t, I would like to bring t plus x, because if I write t plus x for t, x will get cancelled and my question will become more simple. That is, I can write fx is equal to e to the power mod of x minus t plus x dt, and because lower limit and upper limits were 0 to 0 minus x and 2 minus x, that is, it is equal to minus x to 2 minus x e to the power mod t dt. And now, keeping the graph of this in mind, this thing geometrically represent, I am drawing the graph of y equal to e to the power mod t. It will be this. It is clear from here that the length of interval is 2. That is, you have to find the area under this curve where the length of interval is 2. It's clear that area under the curve where the length of interval is 2, say one point is here and one point is here, this length is 2. It is clear that if the length of interval is constant, area under the curve will be minimum in this situation. If it is minus 1, it is 1, then area under this curve will be minimum, because if I slightly go some length alpha, then suppose it is minus 1 plus alpha, it will become 1 plus alpha. It is clear that this area is more than to understand it more clearly. If it is minus 1 here, 1 here, if it is minus 1 plus alpha, it is 1 plus alpha. That is, I shift the ordinate towards right hand side. The area which will decrease is this area will decrease and this area will increase. That is, decrease in area is less, increase in area is more. As a whole, if I shift the ordinate towards right hand side even slightly, the area under the curve will increase. That is, I can say area in the situation minus 1 to 1, area under this curve will be minimum. That is, minus x should be equal to minus 1 and 2 minus x should be 1. From both the cases I am getting the answer 1, x equal to 1. That is, the value of this will be minimum for x equal to 1.